Okay, so previously we have the three main equation. V equals to U plus AT, V square equals to U square plus 2AS, S equals to UT plus half AT square. Again, you don't have to memorize this thing, but if you can, should be okay. And then there's another formula that you can use in this chapter, but they wouldn't give you in the formula sheet. Dia tak kasi dalam formula sheet, tapi kamu boleh pakai. That one will be S equals to half U plus VT. I think this one should be in your lecture notes, maybe ada. But since this one is not given in the formula sheet, so I'm going to delete this one for now. Kalau perlu, saya keluarkan balik. So this three equation, obviously when we are talking about only in the X component, ataupun cerita dia satu component je lah, sebab tu kita tak ada differentiate between X and Y component. But now, if you are involving with two component, that means we have to consider when this one happens in X component and when it happens in Y component. Example, I can write this one as my Vx, Ux, Ax. So the time doesn't have any component lah, because it's a scalar. V square here would be Vx square, Ux square to Ax, Sx. Okay, so basically I just add the subscript x over there. Okay. So basically when I put that one, so we are talking about a motion that involved in X component only. Okay. The key thing here, for a projectile motion, you still use the basic concept of a free fall. Basically, once you throw it, you just leave it as it is. Contohnya saya ada anak panah. Let's say this one is the archer, and this one dia punya arrow, and then dia punya arrow tu dia point in this direction, and then they shoot. Okay, so initially you might have the initial velocity u equals to 10 meter per second, example, and you have a certain angle. Okay, but then once you release the arrow moves by itself, and there's no force acting on it. Dah tak ada yang nak tolak lagi, dah tak ada yang nak tarik lagi. So basically we assume there's no air friction ke apa, kita assume tak ada lah. So the only force acting on the arrow would be apa? Cuba kamu rasa apa? Ada satu force yang akan acting dekat arrow tu. Apa dia? Force yang sentiasa ada.
Gravity.
Yes, gravity. So the only force that acting on this arrow would be gravity. So this is the only force that will be pulling the arrow downwards. So dia daripada sana, dia gerak, dan dia akan turun lah. So this is because of the gravity. The gravity will happens in which direction? Kemanakah gravity tu tarik?
Bawah.
Ke bawah. So to be exact, gravity only occurs in Y component. So I'm going to write down here. So Y component, so where you have a gravity force. Okay. So in another way, another saying, in X component, there's no force. Okay. So if I have my U, I can resolve this one into Ux and Uy. So basically, if I want to substitute inside this equation, kan, I need to use my Ux. Dia bukan U, dia Ux, only in X component. So all the motion, projectile motion, first thing first, you have to separate between X and Y component. Separate kan dia. You have to treat it differently lah. macam dua benda yang bergerak berasingan. Kamu boleh assume arrow ni satu gerak straight like this, another one gerak naik atas, and then dia turun balik. Yang tu jadi kita discuss. Now we want to discuss the X component first. So if you want to discuss about UX, so the motion would be in this direction, and then dia pergi naik atas, but still the UX will be in that direction. In fact, since there's no force acting on this arrow in the X component, there's no acceleration, there's no deceleration on X component velocity. So that means your UX initial velocity will be equals to the Vx. You guys agree with this or not? Faham tak? Boleh terima tak konsep ni?
Yang UX equals to VX tu rasa.
Boleh tak kamu terima konsep UX is equals to Vx because there's no force acting on this object in the X component. So basically once kamu throw, kamu release, dia akan move in the same direction, X component lah. Yang Y je yang berubah, so dia akan turun bawah. But then X component tak berubah. Understand? Okay, ingat tak awal-awal chapter dulu saya pernah kasih contoh what happen when you release an object inside a car. Ingat tak?
Ingat.
So basically what will happen is actually when you sitting inside the car, let's say this is you, and you release your phone, katakan phone kamu jatuh, then what will happen is that this phone, as long as the car is moving at a constant velocity, okay, this object actually will falls exactly below the release point tu. Dia takkan ke belakang, dia takkan ke depan. The main reason is because when you release the phone, this phone actually has a UX. Maksudnya dia tengah bergerak ke depan. And then when you release, it being pulled by the gravity, but the Vx is actually equals to Ux. So that's why dia bergerak bersama-sama with the car. As long as the car is not accelerating lah. Kalau the car is accelerating, then the phone will drop slightly backward. Understand? So this is the concept that we use inside the projectile motion. So X component, there's no force acting on it. So basically, Ux is equals to Vx. Okay, what happened when Ux is equals to Vx? We can say that Ax is equals to 0. Okay, I think I'm going to erase this one a little bit. Oops. We can say that Ax equals to 0. So what happened to our equation when our Ax is equals to 0? So we can cancel out this term. So we'll end up with Vx equals to Ux, which is this one. And then we can cancel out this term. So again, we end up with Vx equals to Ux. And then the last one would be this one. We can cancel out this one as well. Then you will end up with Sx equals to Uxt. Okay. So I think I'm going to move this one to the different page altogether. So as a result, for X component, okay, Ux will always be equal to Vx. So the initial velocity will always be equal to Vx. Okay. Katakan initial velocity dekat sini, Ux bukannya U tau. Ux ni katakan adalah 5. So sampai dekat sini pun dia masih lagi 5. Okay. This is the thing that they wouldn't say it in the question. Dia tak akan sebut pun dalam soalan. Tapi you need to know. Ini adalah hidden information yang memang basic kamu kena tahulah, macam dia sama level macam gravity is there. This is the same meanings lah. So another equation is Sx equals to Uxt. So this is the only two equation for the X component. So sebenarnya senang je. Okay. Now for the Y component, okay, what we will have is that we actually have the equation for free fall motion that yesterday we learned. Exactly the same. Sebab apa? Okay. Even though this arrow is moving in this direction, katakan saya lukis. Okay. So like I told you previously, we can treat X and Y ni separately. Bukan we can, we need to treat X dengan Y ni separately. So over here, you have a UI. Over here, you have a UI. Now it's going downwards, and it's increasing, and it's increasing, and it's increasing. So for Y component, walaupun dia bergerak ke depan like this, you can basically assume this one the same motion with the object you thrown straight upwards. Let's say if you have an object thrown straight upwards like this, katakan kamu baling a stone upwards kan, so eventually dia akan reach a maximum point and then dia akan drops. Okay, another key thing here is that at the maximum point, your velocity here would be equals to 0. This is Vy equals to 0. Kenapa dia 0? Kalau kamu baring barang, at one time dia akan berhenti sekejap before dia jatuh balik. Agree or not?
Agree.
Agree.
That one's okay. Itu konsep senang kot. Okay, another concept, important things. Katakan, let's say you throw this one, Uy equals to 5 meter per second. Okay, katakan 2 meter per second lah, saya pakai nilai lain. So, bila dia reach at the same height, but it's going downwards, the velocity will be equal. So, this one, when it goes down, Vy is equals to 2 meter per second as well. The only difference is that this one is going upward, this one is going downward. So, one will be positive, another one will be negative. Okay, understand?
Understand.
Okay, good. Yang lain okay?
Okay, sir.
Yes,
Okay.
sir.
Okay, sir.
Okay, sir.
Okay, if you're going back to this projectile motion, so dekat sini, that means our Vy is equals to 0. That's one thing lah you need to know. Dan dekat sini, let's say kalau same height, then my Uy punya magnitude will be equals to Vy. Okay. Let's say dia diri dekat a cliff. So dia ada at the edge of the building ke apa kan. So this one going a little bit further down. Kalau dia turun lagi, so Vy tu dah berubah lah. Most likely dia akan besar daripada Vy tu dah bigger daripada Uy. Sebab dia jatuh bawah lagi. Tadi sama, jatuh bawah lagi dia lagi besar lah. Okay, maybe kamu tak nampak sangat, but it's okay. Jadi kita buat soalan, kamu akan nampak. Okay, so since this is the, kalau case macam ni, what can I say about my S? Starting point, this is my region where S is equals to 0. This is my SY. We are talking about SY. Okay, since we are talking about the vertical punya distance, normally we use, vertical punya displacement, normally we use the term height, H. And sometimes student pakai height pun boleh. Contohnya yang ni ketinggian dia, height dia berapa. Basically itu adalah dia punya SY. But I would like to point out, in this region, your SY is positive. Okay, anything below your starting point, your SY must be negative. Kena letak dalam equation. You have to substitute inside equation. So equation apa? Equation tu sama dengan yesterday punya equation yang kita belajar pasal free fall. So we still have the three equation. V equals to U. Instead of A, kita ada minus GT. Dan kita ada V square equals to U square minus 2GS. And then we have S equals to U T minus half GT square. Okay, the only difference here with the yesterday one is that we put the Y punya subscript. Sebab apa? We want to differentiate between X and Y. Okay, yesterday free fall tu kita just cakap pasal Y. So, that's why I didn't put any Y punya component tu. Tapi sebenarnya boleh letak juga yesterday. Okay, the key thing here, I repeat, at maximum height, Vy is equals to 0. Okay, at same height, Uy will be equals to Vy. The magnitude will be equal, but in opposite direction. Okay, and then another thing that we need to know is that this is what we call the range. Okay, the length ataupun the distance from the object being thrown to object being fall, they reach the ground tu, itu kita panggil sebagai range. Sometimes dia pakai terms range lah. Okay, it used to have a specific formula, but nowadays dia dah tak ada specific formula, dia dah keluarkan daripada syllabus kamu. So if the question want you to find the range, you can find one by one lah, satu persatu. Nanti saya tunjuk kau macam mana. Basically kamu nak cari SX dia sebenarnya. So to find the SX, dia daripada X component. Nanti kita pergi dia lagi. So in conclusion, saya simpulkan dulu. Let's say I want to put all these equations side by side inside a table. Katakan saya nak letak dalam table side by side. So it will be X component, Y component. Okay, I'm going to put Y component first because most of the time you might have to solve Y component first. Most of the time, not all the time. Okay, for the X component, you only left with the two formula. Actually satu je, tapi saya tulis juga lagi satu tu, where Ux will always be equals to Vx. Another one is Sx equals to Uxt. Okay, for the Y component, you still have the three formula. Vy equals to Uy minus Gt. V square Y equals to U square Y minus 2GSY. Okay, nanti kamu double check saya punya formula ni. And then the last one will be SY equals to UYT minus half GT square. Okay, so this formula will not be given in exam. Dia tak kasih yang format macam ni lah. So dia akan kasih yang three formula yang asas tu. So basically you need to know bila kamu nak jadikan macam ni, masa bila kamu nak jadikan macam ni. Okay, so I will show you when, which is when it is projectile motion. And then so whenever you get the question in projectile motion, you can list down this equation first. So like I told you before, the first thing is that you have to treat Y dengan X tu separately. Memang kamu kena asingkan. Okay, but ada satu perantara antara dua ni, which is time. So between these two, the only things that connects between these two would be the time. So maksud saya, kalau kita ada motion macam ni, okay, Vy dengan Vx ni dia dah separate lah, memang dah tak related. Contoh dekat this position kan, kita nak kira. So kita dah dapat nilai Vy. Now we want to find Vx. Okay, contohnya. So the only relation between this is the time. The time untuk dia sampai sini ke sini sama. The time untuk dia naik ke atas sini sama. The time untuk dia ke kanan dia sama. Faham tak? Okay. So the relation between Y and X component is time. So most of the time, banyak sangat time selalunya lah. Memang soalan tu memerlukan kamu cari, katakan dia tanya X component kan. Biasanya kamu kena cari Y component first. So you have to find the values in Y component first, and then you have to relate dengan time, and then you have to translate into X by using this equation. Itu contohnya. Okay, contoh macam katakanlah soalan dia kata find the range Sx bila dia sampai dekat maximum height. Okay, you know that you want to find the SX over here. Okay, one thing that you know bila dekat maximum height, kamu punya Vy ni equals to 0. So you can substitute this information inside equation of a Y component. You can find the time taken for it to reach this height. Masukkan balik dalam X component punya equation, then you can find the SX. Okay, that's the idea lah. Again, kalau tak nampak yang part ni tak apa. Don't worry. So, few key things. Maximum height. Okay. For this one, AX will always be equals to 0. Okay. Vy dekat maximum height is 0. AX will always be equals to 0. And lagi satu yang saya cakap tu, kalau same height, Uy punya magnitude will always be equals to Vy, but in opposite direction. So I put a magnitude there lah, in brackets. So direction different, but the magnitude will be equal. Okay, any question? Azmin ada? Azmin dah tak ada dah? Azmin, ada tak anda? Saya tak tahu kenapa dia tidak menyaut, tapi tak apa. It's okay. Okay, so far any question? Ada soalan tak? Tak ada.
Tak ada, sir.
There's no question. Maybe kita boleh tengok few example in the tutorial. Okay, we're gonna start with the... Saya tengok soalan 15 tu apa cerita. Oh, okay. Kita start with question number 16. Okay, I'm gonna give you 2 minutes. Try to read the question. Boleh nampak tak question?
Boleh, sir.
Okay, try to read the question and try to draw the situation. Cuba lukis. Baca dan lukis dulu. Okay, ball kick at an angle 37 degrees above the horizontal. Okay, kita macam biasalah. Mula kita highlight. With a speed of 30 meter per second. Calculate the maximum height, time of flight and horizontal range. Okay, nampak senang? Kita tengok senang ke susah. Okay, this is the object. Okay, saya just lukis dot je. And then the ball is kicked at angle 37 degrees to the horizontal. So this is the horizontal line. So dia kata they kick 37 degrees above that. Okay, and then dia kata with a speed of 30 meter per second. So 30 meter per second tu, is it U, UX or UY? Which one?
UX kan? Tak sure lah, sir.
Tak sure, it's okay. Kita try, don't worry. So walaupun okay, dia kata the ball is being kicked above the horizontal tu, maksudnya dia punya direction lah. Tapi the speed tu represent the speed of the ball. So that one is actually your U. Okay. Jangan confuse dengan word horizontal tu. So horizontal tu maksudnya untuk yang direction je, dia punya angle dia tu. Okay. Now dia kata this ball will move lah, obviously. Dia tak kata dia sepak kat mana. So I would expect, because dia tak cakap dia dekat flat surface ke apa, we assume that this one is a flat surface. I assume dia main bola lah. Takkan main bola tepi bangunan pula kan. Okay. So that means we will have, this is the surface, macam field tu. Oops. So dia punya path, kalau dia naik, dia akan pergi naik sini. I will expect it will go down somewhere over here. Kenapa pensel saya jadi halus? Okay. Okay, now the first question they ask you to calculate maximum height. Dekat mana? Tengah.
Tengah-tengah.
Exactly over here, this one is your maximum height. So I'm going to write this one as your maximum height position. Okay. So apa kriteria dekat maximum height ni? Ingat tak?
B kosong.
Vy is 0.
Apa yang zero? Vy. Okay, very good. So over here, Vy is equals to 0. Soalan dia nak maximum height. Soalan dia nak apa sebenarnya? Kuantiti apa?
Distance.
Distance. Okay, betul? Y component or X component?
Y.
Y. So basically the question want to find as Y. Okay. Boleh ikut?
Boleh sir.
Kita buat terus lah. Kita buat soalan A terus. So, kita ada, kalau kamu confused kan, kamu pergi balik dekat table ni, you can take these 3 equation, you can put side by side lah, ataupun you can take all the equations lah kalau nak. Saya ambil semua. I think I can make it a little bit smaller. Obviously, you don't have to write down every single time lah, but this one I'm still learning. So I just want to write it side by side so that you can see. Okay, now, cara saya selesaikan whenever you have any information that is given, for me, the first thing is that I would like to separate between X and Y. So number 1, obviously you have to draw lah. Okay. Number 2, separate ataupun resolve X and Y lah. Okay. Ni information yang diberi tu semua kamu separate kan. So in this case kamu ada U kan. So the first thing, separatekan between U dengan UX dengan UY. So kita buat tu dulu. Okay. Dekat sini, over here, we are focusing on the first question 16A tu. Vy is equals to 0. Everyone agrees. How about my Vx? Ada tak nilai Vx? Is it 0?
Ada.
Ada. Vx sama dengan?
Dia pecahkan kan. Pecahkan 30 tu jadi horizontal component.
Okay. Betul? Memang betul. Itu jawapan dia. Tapi saya Vx tu dia punya properties adalah equals to Ux. Okay. So dia tak berubah. Ingat So you guys ingat kan? Bear that in mind. Okay. So you don't have to calculate about Vx pun. Okay, now first thing first, kita separatekan Ux dengan Uy. So Ux equals to U cos 37. Uy equals to U sin 37. Okay, ada masalah with this tak? Anyone have a problem with this? Tak ada Kalau ada, beritahu before we go further lah. So this one, you can substitute. So dia jadi cos sebab sebelah tu ada nilai theta. Okay, I got here is 23.94. Sorry, 0.96. You guys get the same with me? Dapat sama tak? Guys?
Sama sir.
Kamu ngantuk So yang bawah ni 18.0. Jangan ngantuk. Kalau ngantuk kamu kena buat benda ni. Okay. Nak kata pagi sangat tak ada. Pagi sangat kelas. Okay, 18.05 and 23.96. Okay. Now, you want to find your SY. Okay, kalau kita tengok dekat equation ni, equation mana kita nak pakai? Boleh tak kita pakai straight terus kat sini? Kita cuba tengok dulu lah. Boleh ke tak pakai straight. So, basically the last one would be choosing the equation. Senang je. Mak tak cukup. Okay, between these three, mana satu kamu nak pakai? You want to find SY, right? Do you have any time? Ada time tak?
Tak ada.
Tak ada. So, kalau kita tak ada time, kita boleh potong yang ni, betul? So,
Betul.
you left with this one lah. Betul tak equation saya? 2A betul lah. Okay, so if you are using this equation, cukup tak maklumat kamu? VY kamu sama dengan berapa? VY kamu sama dengan berapa?
Sama dengan UI.
0.
0. Okay. UI kamu ada kan? Tadi kamu baru kira. 2 ada, G ada, SY you can find straight away. Okay. So you can pick that equation. So to solve, so basically, kan, kalau saya consider this one as still taking out the information. So information ni dia beri. Kamu nak pakai ke tak nak pakai, buat je UX dengan UI. Kadang-kadang dapat satu markah. So just do it like that. Okay, so the solution would be, you can use the second equation where v squared y equals to u squared y minus 2g sy. You can cancel out the v because that one is equals to 0. And then uy you can substitute, which is equals to 18.05. Okay. Sometimes, bukan sometimes lah, every time you substitute, you have to ask yourself, the positive ke negative uy? UI positif ke negatif? Kita tengok balik kat sini. This is your UI.
Positive.
Yes, positive, so it's going upwards. But in this case, kalau equation ni kamu pakai, it doesn't matter pun because you have a square over there. So if you put negative pun dia jadi square juga lah. But then we want to do it the right way. Minus 2, 9.81 and then SY. So you can bring the whole term over here to the other side and then you can solve. So you get 18.05 square divided by 2 divided by 9.81, you should get 16.61. Oops. Okay, you can leave it like this or you can rewrite, therefore okay. Okay, the next question, soalan seterusnya, dia tanya kamu, the time of flight. The time of flight tu time daripada mana, from where to where? Is it from here to here? Or is it from here to there? Mana satu? To there. Sampai hujung lah. So, macam mana kamu nak selesaikan, kamu rasa?
Guna formula balik.
Okay, guna formula balik. And then kamu boleh cari information dekat sini. And then you can solve. Ataupun kamu boleh buat cara lain. You can find the time taken for it to reach this height. And then kamu darab 2. Boleh juga. Sebab we know that this one, dia sama. This one dia memang symmetric. Dia naik, dia turun tu symmetric. So, katakan time sini 5 saat. Dia turun balik 5 saat. So, total 10 second. Tengah fikir nak pakai mana, okay? So, kita buat cara biasa orang buat lah. Yang ini yang bagi 2 ni cara yang tak konvensional sangat sebab tak ramai student dia faham, so saya tak nak sentuh benda tu lah. But you can do that. Saya suka buat macam tu sebab senang, information dah ada. But then we try a different method. Okay, another method is that you can solve, you can find some of the information over here and then you can use parts of the equation. Okay, for me personally, you have to identify kamu ada banyak tahu dekat X ke dekat Y sebenarnya. Okay, contoh maksud saya, dekat sini apa information yang kamu ada? Okay, cuba kita keluarkan. Do we know the Vx?
0, right?
Vx.
VX.
Sama dengan ni lah, 23 plus mana.
Sama dengan Ux, betul?
Yeah.
Because dia tak ada acceleration dekat X component. How about my Vy?
Vy sama dengan Uy.
0.
Dia belum reach the ground tau. So you cannot assume dia zero lah. Dia just before they reach the ground. So Vy ni actually kalau in this case sebab dia same height, so we know that Vy is equals to Uy, cuma dia opposite direction. Okay. Yeah. Sx kita tahu tak? Kita tak tahulah. We don't have enough information right now untuk tahu Sx tu apa. Sy kita tahu.
Tahu.
Berapa?
$16.61.
Kalau 16.61 tu dia dekat maximum height. So positive 16.61 tu dia naik atas. Tapi kalau dekat sini,
Kat mana sih?
dekat sini, kat ujung sini. Kalau dia naik sini 16.61, dia turun balik kat sini
Kosong.
Sebab dia sama height. Displacement in the same height, so displacement dia equals to 0. So Sy dia equals to 0. Again, benda-benda macam ni dia takkan sebut dalam soalan. So you really have to write down one by one lah. So now, kalau kamu nak buat X component, you still don't have enough information. Sebabnya, you don't know the Sx. You do know the Ux, but you want to find the T. So you have two unknowns, so you cannot use the X component yet. Not enough information. So what you guys need to do is that you have to go back to the Y component first. Okay, but now you have the Sy which is equals to 0. You want to find time, so obviously you cannot use this equation lah sebab kamu nak cari time. Okay, so you can either use this equation or this equation. 1 ke 3, mana nak pakai? Dua-dua boleh, I think.
Itu pun boleh kan?
Masalah bila kamu pakai 1 tu,
Tak cukup maklumat kan?
cukup Vy, cukup buat. Okay, kita cuba. Don't worry, we try. Okay, kalau tak boleh, kita tukar cara lain. Okay, let's say we try. So dalam example macam ni lah. Kalau kamu tak sure, just try, just substitute. And then baru kamu nampak kod. Boleh ke tak boleh. So if you are using the first equation where Vy equals to Uy minus Gt. Okay. Now, you know that Uy is equals to, kita start at Uy. Uy is this value. This one is equals to 18.05. So it is pointing upwards, so it is positive lah. Positive 18.05. Okay, how about my Vy? Saya cakap tadi Uy is equals to Vy, betul?
Betul.
Tapi you need to remember that one's for the magnitude. So direction dia ke mana? Kalau Vy. Oops. This one.
Ke bawah.
So positive ke negatif?
Negatif.
Okay, so you have to substitute negative 18.05. Understand? Minus 9.81 T. Okay. So if you're gonna do that, so you have negative 18.05 minus 18.05 and then divided by 9.81. Negative 9.1, which you get T equals to 3.67. 68, sorry. Okay, did you get the same answer with me? Dapat tak?
Dapat.
Okay, very good. So dah dapat, kita dah tak cuba lah equation lain. So sebenarnya equation yang bawah tu boleh juga tak silap saya. Tapi dia jadi panjang lah sebab dia ada T square dengan T tu. Nanti kamu nak kena selesaikan macam quadratic. Maybe kamu confused. So the best way is using this formula. Straight away kamu dapat the solution. Okay, the last question. They ask you to find the horizontal range. So basically the question want you to find apa? Simbol apa ni? Saya nak pakai. Yes, S, X. Okay. So now, Sx, if you are looking at this formula, kita ada satu formula je. Sx sama dengan Uxt. Memang soalan ni biasalah, sekali dia tanya Sx, find the range. Okay, since we know that Ux is equals to 23.96, it is to the right, so it's positive. And the time of flight, macam saya cakap tadi kan, time tu perantara. So maksud saya, oops. Time untuk dia pergi sini is 3.68 second. Time untuk dia gerak straight is 3.68 second. Time untuk dia naik and turun balik kat tempat yang sama 3.68. Itu konsep dia. X, Y perantara dia adalah time. So darab saja. You should get 88.17. Okay. Macam mana? Okay ke tidak? Okay. We really need to stop now because I think saya dah terambil masa kamu 5 minutes pun. So, kita stop.